So as it says on the bottom of 3, we want a test that has more sensitivity. The biopsy is more expensive, it's more invasive, but you'll tend to reduce these false alarms and these misses, and you'll get a correct result, because we don't want to make errors. In an asthma program, who cares? But in cancer, you care a great deal, and we really want to minimize which error in particular in the cancer situation.
Type 2.
You really want to minimize the type 2, and that's really very important. So the biopsy will really determine things in a good way, and we're always looking for better tests that will be more sensitive and more valid and more accurate for getting results. So we move on to Roman numeral 4 here. In statistics, we've talked a lot about this 0.05 thing. Kind of a line in the sand, right? You're either significant or you're not. That works for some people, but instead of that, what some statisticians like to do is they like to talk about something called confidence intervals. Have you guys come across confidence intervals in some of your readings? Take a look at the asthma study here. I've only got 3 people in it just for the sake of example. Does it actually look like the program worked here? Does it look like the program worked here?
Numbers are all going down, first glance.
Yeah, it looks like the numbers are all going down. Let's actually go, and I'll illustrate this on the computer as well. What kind of study design is this? Is this like the Alzheimer's? I would argue it's...
It better look like it's worse because it's smaller.
I would argue it's not quite like the Alzheimer's situation. I would actually make these 2 column labels pre and post. What kind of design is this?
Pre-post.
It's before, after. Whoops, what happened there? Oh my. Holy Toledo. Well, my 6 people were subjects on various lines here, so we'll move over here. Yeah, we have pre-test, post-test. It's a within-subject intervention design here. So could we do the statistics on this? Sure. But notice what I've set up differently in SPSS here. How many total subjects do we have here?
3.
Just 3. So pre, it's very important to keep the same subject on the same line. 7, and at the end, 1. Then what do we have? 10 and 5. And then for pre on the 3rd subject, it's 8 versus 4. Does it look like the program worked here?
Yes.
Why would you say yes to this question? You would be correct. What number would you use that we talked about even with the other t-test? What's the numerator?
Testing effect.
The treatment effect. What's the treatment effect here? Say again?
Is whatever they did changing their quality of life?
The change in the quality of life. So 10, 7, and 8. You add that up, you get what? 25. 25 divided by 3 is what? 8.3. Post-test, we have 5, 4, and 1. Did I put the right numbers in here?
Yep. 3.3.
10, 5, 8, 4. Yeah, you've got 10 here. What is it at the post-test? So what's the treatment effect here?
5.
It's 5. Is 5 probably going to be significant here? It probably is. So let's go and do the statistics. Analyze. Now where do we go?
Compare means.
Compare means. Which kind would we choose here?
Paired samples.
Paired sample t-test. It's important to have the same person in the same cell, so we put the pre for variable 1, the post for variable 2, and we click it on the magical button, which is OK, and we'd run it. Does it look like we have good results here?
Yep.
Yep, could you write out a T statement here?
Yep.
Yep, T, how come it has 2 for DF here? Degrees of freedom.
Because you have 3 subjects.
3 subjects, it's a very small subject sample here. T of 3 equals what? 8.66. P equals, P equals 0.013. Good news or bad news?
Good news.
Good news, less than 0.5. Would I be happy with the Tausman asthma program? Sure, and I would get hired by Jefferson College in Roanoke, Virginia, and get out of Rockford, Illinois, where it's cold and wintry most of the time, and so that would be good news for me. So
Though if I were reviewing a manuscript that only had 3 subjects,
you would never publish this because the external validity wouldn't be there. You wouldn't be able to generalize on the basis of 3. You're exactly correct with that. The 6 and 6 worked out. We got published in a smaller journal with that. It was still a very small sample size. It was more about the design of the program that was important. This is just, you're correct, a statistical example going on here. So the idea of a confidence interval, though, we have statistical significance here. But sometimes people don't like that line in the sand. So we form a confidence interval. And so the idea there with a confidence interval, and it kind of gives you some information here, if you wanted to join my program, and on the basis of these data, if you had to give a point estimate, how much is my program going to help you? What would be your point estimate? If you had to say, here's how much, based on the data I have, only 3 people, not very many, based on the data that I have here, how much would my program probably help you?
between 2.5 and 7.5.
But if I want it to be one number, 5, you could have a confidence, or you could say, I think my program would help you out by 5 points. That would be a very precise, you'd have a lot of precision with that. Your point estimate would be 5. You would be highly precise. Would you be confident about that? That it's going to help each and every one of you out by 5?
95% confident.
You'd want to form a confidence interval. So that's what they do. So if you have a point estimate, you have a very precise number, one number, and it would be 5, the treatment effect, but you wouldn't have a lot of confidence in that. What you would do is you would form a confidence interval. And if you look at the confidence interval here, look what it does here. You are 95% confident, and if you want to write this down, you are 95% confident that the Tausman program will help you out between how much?
2.5 and 7.5.
2.5 and 7.5. So a confidence interval. I am 95% confident that my program will help you out between 2.5 and 7.5. Do we have the precision there?
No.
Not quite as much, but do we have a lot more confidence in this?
95%.
95% confidence. So confidence intervals are often done. So confidence intervals are often done, and the idea here is I am 95% confident that this program will help you out between 2.5 and 7.5. It's giving you a range. Is it saying significant or non-significant here? No. People doing confidence intervals don't like the line in the sand idea. Does this idea with confidence intervals make sense to people? I thought the asthma example was kind of a good way to go with that, because then you can see the point estimate, which is 5, a lot of precision, but not a lot of confidence in that. 95 is usually the confidence interval shown. You could have an 80% confidence interval, and then it would be even larger than that, but then you lose some of the precision. It might be, I think my program might help you out between 1.5 and 8.5. So 95%, and it's centered around what number? What's in the middle of 2.5 and 7.5? 5. So the confidence interval, it uses the standard deviation and some other mathematics, but that's what that means. Does that help people out? Do you see that a lot in the research that you guys do? So it's not saying significant or non-significant, it's saying, here's how much, and we have 95% confidence in this, that, or the other thing. Okay.